Hey guys, welcome back. Today we're going to be working on some more multi-step equations and reviewing them. Um, but we're just going to introduce a couple of new concepts here. And our focus today is going to be on special cases of multi-step equations. All right. So it's not going to be too long here. We've got three different examples of very similar looking multi-step equations. All right. So our goal for today is we're going to solve these equations like we know how to, but we're going to analyze what's the difference when we have no solution, one solution, or infinite solution. All right, so we have, again, three equations, and we're going to solve them pretty similarly. So I want you guys to pause the video right now and solve all three equations the best that you can, and then come back when you're done. It's really important that you guys are actually trying to solve this on your own and not just waiting for me to do it for you. Okay, so again, right now go ahead and pause it and come back when you are ready. Alright, so we have the equation in blue on the left here. Our first step is we're going to combine our like terms, right? So that's what we did right there. 2x and 5x, they're on the same side of that equal sign, equals 7x. And then, so we have now x's on both sides. I have a 7x on the left, 5x on the right. I want to get rid of the smallest x value, which is 5. So I subtract 5x on both sides. And then that gives me a 2x on my left side. So 2x minus 4 equals negative 2. I add 4 on both sides. I get 2x equals 2. To get rid of that 2 next to the x, I've got to divide. X equals 1. So all that, I have one answer. One answer is x equals 1. So we'll call that one solution, right? Meaning that there is only one number in this entire universe that I can plug in for x that will make this equation true. Okay. By making this equation true, I mean if I took that 1 and I plugged it back into the original equation for x, the left side will equal the right side, right? And again, the only number in the world, in the entire universe that would work would be 1. Okay, so let's move on to the middle question, equation in red. So we solve it the exact same way. We're going to combine 2x plus 5x first. And then you notice at this stage right here, I have 7x minus 2 equals 7x minus 2. It's the exact same thing on both sides. So if I want to take it to the next step and I want to get rid of my x values, there's my smaller x. They're both 7x, so my smaller x is a 7x, right? So I subtract 7x on both sides. I'm going to get negative 2 equals negative 2. So what does that mean? What happened? What's going on? Why don't I have an x value anymore? Well, what happened is that this situation is saying that I can plug in any number in the entire universe into x. Any number that you can think of, right, into x. And so there's an x there, there's an x there, there's an x there. Any number I can plug into, no matter what I plug into it, the left side will always equal the right side. Any number. Because it's any number, we call that infinite solutions. Okay? Any number you can think of, this is going to work no matter what I plug in. All right. So far we have one solution on the left, infinite solutions on the middle, and then on my right, I have, again, it's kind of following the same steps here. We're going to combine 2x and 5x, we get 7x, but at this point we get 7x minus 4 on the left, and on my right I get 7x minus 3. So once again, if I subtract 7x on both sides, I'm going to get rid of that 7x. What I have remaining is a negative 4 equals a negative 3. Well, ask yourself, is that true? Does a negative 4 equal a negative 3? Is that the exact same thing? Because of my x values I don't have an x anymore. I just have negative 4 equals negative 3. That is clearly not a true statement. This means that no matter what number I plug into x, nothing that I'm going to do, no number in the entire universe can I plug in for x on the original equation is going to make this equation true. So because of this, there are no solutions to this equation. Okay? No solutions. So, recap. My left side, I have an x remaining. X does equal 1. So we call that one solution. my middle equation, I don't have any x values anymore, right? I just have a negative 2 equals a negative 2. That means it's an infinite solution, because no matter what I plug in, it's going to still equal each other. Then my right equation, I don't have an x value anymore. And I have a negative 4 equals a negative 3. We know that is not true, so we call that no solution. All right, so make sure you guys solve this all the way through and you are understanding what each of those mean. Okay, let's move to the next slide here. And we've got a little bit of a triple bubble map here. So I want you guys to just come up with some examples here that will, some characteristics of each one of these bubbles. For example, I'll do the first one for you. One solution has an x equals a number, okay? And this means that there is only one answer that would make this work. Okay, so that's a one solution. So I want you guys to pause the video and give me some examples, some characteristics of what an infinite solution looks like and what a no solution looks like. Okay, come back when you're done. All right, so here I have some examples for infinite solutions. In infinite solutions, again, any number would work. Right? No matter what I plug into it, it's going to work. A possible answer I would have would be x equals x. Right? If I just have x equals x, there's no other numbers remaining on my equation. That's an example of an infinite solution. Or if I have a number equal itself, 5 equals 5, or negative 2 equals negative 2. Or I could use a different variable than x. I could have y, so y equals y, or something like that. Okay. And at this point, why don't you guys take a minute to give me some examples of a no solution. All right, so this for no solution, my variables are eliminated. Okay, there's no more x values or y values. Kind of the same with the infinite solution. There are no more variables, right? I know you see x equals x, y equals y, but I could technically subtract x on both sides or y on both sides and eliminate my variables. So for back to a no solution, once the variables are eliminated, I'll have a remaining number like this. A negative 3 equals a positive 2, or a 5 equals an 8, something that is not true. That's what no solution is. So it also means that no numbers in this entire universe will work. When you plug it into your variable, you will not get an answer. All right, so going back to the one solution, it's real simple. It could be x equals 5, it could be x equals negative 2, it could be x equals 1 million. It doesn't matter what it is, you will have one exact answer. All right, so hopefully that made sense. Let's do a couple of examples here. So I want you guys to pause the video and solve this and tell me how many solutions it has. Okay, come back when you're done. All right, so to start this problem out, we're going to distribute that negative 4, and we're going to get negative 4 equals, or excuse me, negative 4 plus 24a, because a negative 4 times a negative 6a is a positive 24a. On the left side, I just bring down the 24a minus 22. So my next step would be to get rid of my smallest variable, and they're both sides have a 24a, so that's by default that's the smallest. So I'm going to subtract 24a on both sides. That will cancel. I get a negative 22 equals to negative 4, and we know that that is clearly not true, so there are no solutions to this equation. All right, let's try another one here. Do the exact same thing. Go ahead and solve it and see how many solutions we have. What would the solutions be? Okay, so go ahead and pause the video and come back when you're done. Okay, so at this step, or the first step is just to distribute, right? My left side in red, I distributed the 12 to the 2k plus 10, and I get 24k plus 120. On my right side, I did it in green. I distributed the 8 to the 3k plus 15, and I also get 24k plus 120. So as soon as you guys, I can identify that the left side is exactly the same as the right side, from there, you can go ahead and say that this is infinite solutions. So when the left side is exactly the same as the right side. Okay, and if I were to take it to the next step, I'll prove to you that it would work. So again, infinite solutions means I can plug in anything for k, and I'll still have the left side equals the right side, right? So my next step would be to subtract 24k. I don't really have to do this. I just want to show you. So I get 120 equals 120. You could even take it to the next step even further and subtract 120 on both sides. And I'm going to get 0 equals 0. Okay, so that would be infinite solutions. All right. That's pretty much it for our lesson today, guys. I just wanted to go over the special cases that we have. So your closure problem, I want you guys to just answer the following question in your notes. And the question is, how do you know if an equation has one solution, no solutions, or infinite solutions? And the more thoroughly you answer this question would show how well you actually understand these concepts. All right, that's it for today, guys. I hope you all have a great day, and hopefully I will talk to you soon. Bye.